After discussing atoms and thinking about all of the components of matter that you've discussed through chemistry and biology, it's often confused to think that that's the end of the story. But in physics, as I mentioned, we look past the electron cloud and focus mainly on the nucleus. The nucleus, being 99% of the mass of an atom, really does determine the characteristic physics of the atom. And as physicists have dug deeper into the nucleus and into the atom itself in order to learn more, they have learned that the atom, of course, is not the smallest possible particles. Those particles are referred to as fundamental. Fundamental particles are the smallest possible form of matter as it exists in our theories today. Being the smallest possible, another way to think about this is that they cannot be broken into smaller pieces. And so if we go back to the atom, an atom is actually broken into a nucleus and electrons. And then the nucleus is broken into protons and neutrons. And within that system, we break those things down into three categories of fundamental particles. The first of which is called quarks. Quarks are particles, fundamental particles, found inside the nucleus. As such, quarks are the particles that determine the characteristics of the nuclear particles, which we've already identified as protons and neutrons. What's interesting here is that there are actually combinations of triplets, three, they combine in threes, in order to form protons and neutrons. This is very interesting because the most common two forms of quarks are called up quarks and down quarks. And protons and neutrons are actually entirely comprised of up and down quarks. This is why protons and neutrons are relatively the same size, but does also explain why protons have positive charge and neutrons are neutral. Protons are comprised of two up charges, up quarks, and one down quark, whereas neutrons are two down quarks and one up quark. That triplet combination not only determines the mass and makes them essentially the same, but the interaction is what drives protons to be positive and neutrons to be neutral, despite their other similarities. Outside of the nucleus is our second fundamental particle category, which is called leptons. Leptons, of course, being found outside the nucleus, are easily identified as an electron is a lepton, but there are other leptons that are of relevance, especially when it comes to physics. These particles are known to interact with the electromagnetic force, and so they are affected by charge. So, of course, an electron, being negative, is attracted to a proton because it's positive, but there is also a secondary particle, electrons, and neutrinos are another particle. These neutrinos are leptons, and they are found outside the nucleus and do interact with the electromagnetic force. And beyond that, these are probably the most interesting and least understood particles in today's theories. We know they exist, we know they are abundant, we know they are important, but we don't necessarily know why. Lots of experiments being done around the world currently studying neutrinos. The third category is the link between these two, leptons and quarks. These particles are called bosons, and they are often referred to as force carriers. Bosons are how leptons talk to each other and how leptons talk to quarks. They are also how quarks talk to each other. And if we think about bosons as the force carrier, you can imagine that if I was willing to talk to you, there has to be something that moves from me to you in order for you to carry that information. right, or to learn that information. And the same thing is true for a proton. If a proton is positive and an electron is negative, which they are, and they wish to attract according to the basic rules of electromagnetism, the proton has to know that the electron is there. Well, they don't talk in the classical sense of sound, and they certainly don't send signals like a telephone, but they do transmit a boson particle from one to the other in order to locate and then send back information of the type of particle being interacted with, how strong the force should be, and what should happen next. Bosons are another particle category that is being studied throughout the world because there are a number of bosons, quite a few, and they all do different jobs. And we'll actually be discussing the boson jobs and particles that exist in the next video on fundamental forces.